Cool, let's get started. Hey folks, I'm Simon, thanks for having me. I know I'm the last talk before lunch, so I'll make it worth your while. I'm here to talk about using Codemods to refactor your JavaScript using JavaScript. So real quick, here's some quick background on me. I'm a senior engineer at Rent the Runway based out of New York City. I'm on RTR's site performance team and was previously the tech lead on a few consumer-facing teams. RTR is an e-commerce platform where you can rent your dream outfit. Happy to chat about RTR afterwards if you folks have any questions. P.S. We're also hiring, so come talk to me afterwards if you're interested. I'm also a part-time instructor at General Assembly in New York. I've taught evening courses in front-end web development, JavaScript, and Python, as well as many short workshops. So let's get started. I'm sure some of you folks are thinking, code what? So what exactly is a code mod? Code mods are scripts used to help with refactoring code. The term originated from a tool named Codemod that was open source by Facebook. This first tool used regular expressions in Python for the refactoring scripts. Facebook also open sourced jscodeshift, the tool we're going to see in today's talk. Essentially, we can programmatically refactor the JavaScript files in our codebase by writing transformers in JavaScript. That sounds pretty wild, right? Actually, if we think about it, code mods are pretty mainstream. If you've ever had to upgrade React, there's a good chance that you've seen code mods mentioned in the blog posts and the documentation. So personal opinion alert, but I think mainstream technologies are great. There's a lot of risk with using bleeding edge or not fully baked libraries, especially with production code bases. When writing code at work, I'd much rather use a mainstream library. OK, now that we're done with my personal opinions, what would it actually look like if we ran the code mod mentioned in that blog post from before? So here's an action. So if we take a look at each of the individual parts, this is what the command I just ran looked like. jscodeshift is a NPM package. It's installed globally, all that good stuff. We're going to see later on in today's talk. It's a tool that we'll use to actually run the code mods. And here's a quick before and after of what a React component might look like. Notice how React.createClass was changed to an ES6 class. This is what the code mod allowed us to do. And we didn't have to write any code ourselves to make this change. There were a few other changes too, such as the property initializers that you might notice. OK, I'm sure some of you are not yet convinced that code mods are worth the hassle. Why bother with them? You might be thinking, hey, I have regular expressions, right? You can make complex find and replace changes with even more complex regular expressions. But code mods allow for changes that are actually infeasible with the regular expressions. JavaScript, the language itself, is a first-class citizen when writing code mods. Regular expressions, however, can only understand the text content of a piece of code. Furthermore, code mods actually unblock application-wide refactors by making them easier to perform. These changes might be required because the library, like React, as we saw previously, has updated its API. We could also have updates to an internal API in our code base. You might want to adopt a new pattern or a new standard. These are changes we'd have to make manually if we didn't use code mods. Also, the JavaScript ecosystem as a whole just evolves at a lightning pace with language and library updates. Your code base will have to evolve over time as well. You might have files that haven't been touched in years. And this usually results in tech debt. But code mods help us reduce that tech debt by performing programmatic refactors to modernize our code bases. Lastly, code mods, when used properly, will save significant amounts of developer hours when refactoring an application. At Rent the Runway, we've saved hundreds of developer hours by using code mods to modernize thousands of JavaScript files. And that's great and all, but honestly, they're just really fun to use as well. So why don't we talk through some possible refactors we can perform on our code bases. So let's walk through some of them. We can use code mods to refactor older ES5 syntax into ES 2015 plus. There are a bunch of ones out there. There are ones for changing from require statements to import statements. We can take function expressions and transform them into arrow functions. We can see that later on today, and so much more. As we saw previously, there are code mods to make upgrading React easier. You can use them to refactor your components to unblock upgrades as React's API changes and evolves. If you currently have prop types, there are actually code mods to convert them into TypeScript types. This is super exciting, and it should make adopting TypeScript much, much easier. If if you folks are into that. So hopefully by now, you're all convinced that Codemods are worthwhile. So let's review how Codemods using JSCodeshift actually work internally. And we'll see the concepts we'll need to implement our own Codemods. Here's the GitHub repo for JSCodeshift. It was open sourced by Facebook. We'll use JSCodeshift to run Codemod scripts on our files. All of that tooling is already set up. Here's their official description from the README. I'm really glad that that build is passing. That's a good sign. So this first part is the easy part. JSCodeshift will run our transformation scripts against the files we want to refactor. It'll also provide a nice summary in the end as well. You saw this before. So here's an example of using JSCodeshift along with a summary of the output. We're passing in the transform file, class.js, from the React Codemods repo. The input is this to-do folder that I have. It's in the same directory and all that good stuff. JSCodeshift also has a bunch of handy options for adjusting the number of CPUs that the package uses, performing dry runs without making any changes itself, ignoring files, and we can also provide our own, as we have here. OK, so we saw the first part. That was fun. The second part is also fun, but a little bit more difficult. JSCodeshift uses the Recast package internally. It has whatever methods Recast has, but provides a more convenient API for those methods. So what's Recast? There's a GitHub repo for Recast. Recast is a package we can use to parse a piece of JavaScript code, manipulate that code, that is actually transform the code itself, and then finally return it back out. It's great because if we use Recast properly, it'll actually maintain the same style as the original code before any of our automatic refactoring. Let's focus in on that parsing step. Recast supports different parsers like TypeScript, Flow, and Babylon. That's the parser behind Babel. This means that JSCodeshift itself also supports these parsers. That does raise a question, though. What exactly happens when Recast parses our JavaScript? Recast generates an abstract syntax tree, or AST for short, from our JavaScript. Don't worry if that's how you feel right now. Let's actually take a look at abstract syntax trees real quick. An abstract syntax tree is a data structure which represents a piece of code. It includes all the relevant language constructs. Abstract syntax trees are widely used in compilers. Plenty of tools that we all use day to day, like Webpack, ESLint, Babel, make use of abstract syntax trees. So it's not quite like that tree right there, but it's close. Let's talk about this tree aspect. So trees are data structures that consist of nodes that are linked to one another. Here's an example of a tree. At the top, we have node 1, which is our root node. We can also see that node 1 is the parent node of node 2 and 3. Also notice how node 2 also has 2 children as well. If you're not familiar with the tree data structure, I highly encourage you to dig into them more. They're pretty neat. Going back to our abstract syntax trees, the nodes in the abstract syntax tree describe the structure of our programs. So let's take a look at a node. Here's an example of the AST node for the string hello world. With JSCodeshift, the nodes are plain JavaScript objects. There's no magic going on here. We can identify nodes by their type. If we take a look here, this node has the type literal. For a more complex example, let's take a look at this function declaration. We can see that the type is function declaration, spoiler alert, and we even have access to its name and so much more. What's great is that we can use this tool, AST Explorer, to actually inspect the abstract syntax tree for a piece of code. We can just plop it in there and see the actual tree itself. We need to manipulate the AST in our Codemods. So this tool will be extremely helpful, figuring out the structure of our current code, as well as what types we want in the end. So we can go even further. Recast uses this AST types package internally, which actually wraps the nodes in our abstract syntax tree into these path objects. Path objects are great because they let us do tree traversal, iteration, node modification, so much more. And the package itself also includes builder methods that are also exposed in JSCodeshift for creating nodes in our AST. So let's take a look at what this does for us. So we have our tree from before. Because of the AST types package, we can traverse our tree from node 4 to 2. We can also modify nodes. Let's say we're done with node 2, want to make it better. We can change that into node 6. And going even further, we can actually start to add new nodes. Here, we're going to add a child node to node 3. So if we start to combine these concepts together, we can begin to actually write code mods. So let's dive into that portion. Here's a general overview of the process. First, we'll need to parse our source code to actually generate the abstract syntax tree. After that, we have to modify the abstract syntax tree as required for our refactoring goals. This means we'll probably have to traverse the tree to figure out which nodes we care about, access them, and then we have to update those nodes as well. And finally, using our modified abstract syntax tree, we can actually regenerate our source code. And our files have been modified, our refactoring is done. So we can perform this process in a transformation file. It's just like any other JavaScript file. And we'll pass this transformation file to jscodeshift. The transformation file itself is just a JavaScript module, and it exports a function that returns our modified source code. So we have to do those 3 steps from before. We're going to parse our source code in this file. We're going to update our source code as required, and then we'll return our updated source code. So let's take it step by step. If we take a look at the parameters of this function, we have 3 up there. First parameter, file, gives us access to the file's path and the source via the first argument. This is the file that we want to refactor programmatically. Second argument has methods that actually alias to jscodeshift, and they also allows us to collect statistics and generate reports, all that good stuff. The last argument is an object that contains all the options we actually passed to the jscodeshift command. So this includes any user-defined ones, which means that our code mods can be extremely flexible. So if we take a look at the basic setup for our function, we usually have the jscodeshift library itself alias as j. It's a very convenient variable. It's a lot easier than typing everything out. And then we can use jscodeshift with that j alias to actually parse our source code of the provided file. jscodeshift will handle passing in each file one after another. We don't have to worry about that aspect. And here, we're going to return the root node from our abstract syntax tree. Usually, folks like to chain these methods together. We'll talk more about that in a second. I separated them out just so that we can see them easily. After that, we have to modify the abstract syntax tree. That's a little bit more involved. And in the end, we can generate the source code by calling the toSource method. So here's where things get interesting. At the very bottom, we're returning some value, right? It's just a string. And if a string is returned and it's different from the original source file, then the transformation was successful. Go us. If the string is returned, but it's the same, then it was unsuccessful. Something went wrong in our transformation. And if nothing is returned at all, then that is OK. That just means that that file wasn't supposed to be transformed. We're still good to go. So let's talk about this root node real quick. That root node variable, it's an example of a collection in jscodeshift. These collections consist of Recast's path objects. So that path objects that we have from Recast, we group a bunch of them together, and then we have this collection in jscodeshift. And those path objects, they're just the nodes in our abstract syntax tree. These collections are pretty great. jscodeshift's collections have methods exposed for finding, traversing, and updating those nodes, but the API is extremely convenient. And it's convenient because these methods tend to return collections. It's a lot like how we would write jQuery back in the day. When we use jQuery, we usually have a collection of DOM nodes that are returned, and we start to chain methods. It's the same principle here. So jscodeshift actually implements a fluent interface, and it relies heavily on method chaining. We have this collection. We can start to call methods upon methods on that collection until we're done, and we can return the source. So you can actually write these transformations in the ASC Explorer tool itself. It is extremely convenient. If you're writing your own code mods, I highly recommend starting here. All you have to do is specify that you want to enable the transform option, then choose jscodeshift as the option there. And we can see the transformation here and what the output is. This one is a little bit silly because all it does is reverse the characters. So maybe not the best code mod out there, but it's cool. So let's take a look at a more realistic example. let's write a code mod together to transform function expressions into arrow functions. Arrow functions are very hip, so let's go with that. So let's define what our use cases are. First place that we want to start is determining what we want to support for our transformation. So at the very top, we have function 1. It's like any other function expression. It just returns the sum of those two parameters. Looks pretty benign, and we should be able to transform it easily into this arrow function right here. Notice that it is super fancy, right? There are no curly braces. It's super clean. So we have to handle that in our transformation somehow. We'll see that later on. For function 2, we want to add in an additional case, right? For function 1, there's nothing else in the body of our function. We'll make sure that if there are any variable declarations or any of the work that's happening in the body of our function, that we support that as well. It's good to build out these test cases. It's almost like writing unit tests. So here, we'll have a num3 in there. We'll just set it to 0. It's not going to do much for us, but we'll make sure that that is preserved after we transform it into an arrow function. The last one, function 3, that is a case that should not be transformed. So if we take a look at it, we're using the this keyword inside of that function. And the this keyword is handled differently with arrow functions. We want to make sure that we don't change the actual functionality in our code. So we don't want to automatically transform that function into an arrow function because the value of the this keyword could change, leading to a different value than the original function expression. So we just want to avoid functions like function 3. We have to actually write logic in our transformation to make sure that we avoid those kinds of functions. All right, let's do it. So first thing we need to do is actually grab all the function expressions in our file. So we're going to find all the function expressions. Find is a method that is exposed by jscodeshift on collections. And we can figure out the name of that type by using the AST Explorer tool from before. So we're going to find all the matching nodes that are function expressions, and we'll access them through this fn expressions or function expressions variable here. It's a collection of path objects. And once we have that collection, we can start to actually put logic in it. So one thing that we want to do is we want to avoid the this keyword. We saw that before. It's a lot of trouble. We're just going to avoid those cases. We don't want to accidentally break any of our other code. So we have to write some code to filter out the this keyword. So here we have a filter method that's exposed by jscodeshift on our collection. We're going to pass in this callback function. And this callback function, it's not too bad. What it's doing is it's searching for each of the individual function expressions. And it's making sure that this expression isn't there. We want to avoid this keyword in our transformations. So we're going to exclude any functions that have the this keyword. Size and related methods are just exposed by jscodeshift. OK, so this last portion is a little bit hairy, but let's talk through it. So essentially, fn expressions know this, right? This collection right here, it has all the function expressions we want to change in that file. And now we have to actually make the changes. So we're using the replace with method that's exposed by jscodeshift. And what we're doing is we're going through all the function expressions in that collection. We're going through them one by one. For each of them, we're grabbing the body content, or grabbing any parameters we need. And we're going to do something that's a little bit interesting. We're going to check to see if we can actually transform those into one-liner arrow functions. Those very clean, very pretty one-liner arrow functions. So we're going to do some work in here to double-check that we can actually make those changes. All these values are from the AST Explorer. You don't have to memorize them or just know them offhand. Nobody is born knowing those values. So we can use that tool to figure out what we care about. And once we verify that this one-liner is safe, you can make any changes required. So one thing that we have to do with these one-liners is verify that when we make these one-liners, we have to get rid of that return keyword and use the first argument instead. So at the very end, once we've done all that work, right, we've changed our function expressions into arrow functions. We have to regenerate our source code and return it back out. So in the end, we get back a nice string. jscodeshift handles updating our original files, and we're good to go. So we just saw an example of how to write a code mod, but let's talk through some tips for actually working with code mods in your actual code bases. That was a very small example, but we all probably have hundreds or thousands of JavaScript files we have to update. So let's go through some tips to handle those cases. I learned most of these tips the hard way, so you folks can benefit from my past frustrations and mistakes. So the first thing is I highly recommend having a safety net in place before even attempting to use Codemods. At Rent the Runway, we've only used Codemods in applications that had extensive unit and integration testing. Anything that didn't have that was not applicable. We don't treat pull requests with Codemods any different from regular changes, meaning we still do things like the usual code review process and things of that nature. We shouldn't treat Codemod changes any different than regular changes. The other thing I recommend is when merging in any Codemod modified files, don't make any other changes in that branch. Don't change anything yourself. So don't rename an identifier, don't adjust white space, just do not do anything else. So modifying the code manually actually makes it harder to undo and redo any transformations. If you absolutely need to make manual changes in that file, then you should explicitly point them out in your pull requests. But otherwise, I would just say avoid making any changes yourself. Let the Codemod do that work for that pull request. The last part, if possible, split up these large Codemod refactors into multiple smaller pull requests. It'll make it much easier to diagnose any bugs after deploy. And if it's possible, I would even just deploy these all separately. So this way you can roll back very easily if there is a bug in your Codemod change. And as you go along, write documentation. This could be internal documentation for any Codemods that you use. Even if it's from Facebook or some other company, just write documentation yourself in your company. Because eventually, somebody will get blamed that automatically refactored code. And if they see an empty pull request description for a 1,000-line change, that is not a good thing. So try to write documentation. I recommend putting links to documentation in your pull request descriptions. And if it's an external Codemod, make sure you refer to the version itself in the pull request. The version might update, the actual Codemod itself might update, so make sure that you can refer to a specific version. If somebody else has to revert your code, they should have enough information to reapply that transformation later on. Also, I highly recommend treating any Codemods you read internally as actual code. You want them in a repository of their own, and you should version them as well. This will make it much easier if any of your Codemod changes are reverted, if you have to apply those transformations again. Also, it helps if there are any bugs in your personal Codemod scripts. So that way you can remove those versions or just highlight to people that they should not use those versions. When writing your own Codemods, don't try to worry about handling every single case. If there's hard to reason about edge cases, just exclude them from your transformation script. You don't have to modify every single file in one go. You can update those files manually later on in separate pull requests. And it's honestly, it's okay if you can't handle every single case in one go. You'll notice that a lot of the Codemods that are released and are on GitHub state which cases they don't handle. We saw the same thing for the arrow function codemod that we just wrote. There's definitely a time trade-off. So if you see yourself spending too much time writing a Codemod, just do the changes manually. With all that said, thank you folks so much. I hope you all have fun using Codemods next week at work. Or right now.
Okay, so we have a question came in from Fred. So how do you manage CSS and non-JavaScript resources?
Cool. Okay, so the question was, when using Codemods, how do you manage CSS and non-JavaScript resources? Mm-hmm. So the jscodeshift package itself will filter down to JavaScript files. And you can actually pass in additional parameters to specify which files you want to consider, which files you want to ignore. And one thing that I've done before is actually I've written bash scripts. You can also use JavaScript, but you can write a script to wrap your jscodeshift execution as well.
Okay, gotcha. Sorry. That was not the question I was supposed to ask you. That was for another question. Someone sent in a question for another talk that's coming in the future. Oops. I'm sorry about that.
It's a very interesting question, though.
Well, thank you for answering that. Okay. So I actually kind of want your take on something. So as we've all seen, a lot of these talks since this morning have been about taking preventative measures. And now like we're talking about refactoring and, thinking about like just the long-term effects of our software and like how far it will go in the future. And like whenever, we go on from somewhere else or when someone comes on and takes on over our project, like, how they're able to like get up to speed quickly. So kind of, do you have any like kind of thoughts or like any opinions on just like long-term maintenance and just like really just giving your code base the love it needs?
That is a great question. Long-term maintenance is very hard. So I started at Run the Runway as like the lowest level on the totem pole, and over the years somehow became the service owner for our website. And there's a lot of code that I did not write, and none of the employees that work there right now wrote. And I think one thing I would say is if you can document anything that is weird, just please do it. Like write a single line comment. You don't have to make it fancy. Just this thing is weird. Don't change it. Don't look at it. Just move on to the next file. Okay. But otherwise, I would say try to write your code assuming that someday it will be deleted. We saw with Daria's talk that if you can write wrappers, if you can make it easier for people to remove stuff in the future, then that's awesome. Mm-hmm.
Okay, so what are some of the most ambitious code mods you've seen in the wild?
Ooh, that is a good question. So honestly, I thought that React like change from create class to like EXist classes is insane. If you folks have time, I don't know, later tonight, sometime in the future, just read through that code mod file because it is insane and it handles so many special cases. I just read through and I was like, wow, like I don't know how somebody like, I don't know how these folks like manage to handle all those cases.
So one thing that this is the second time that the topic of ASTs have come up, abstract syntax trees have come up. Do you think that in like your, as your career or like your time as a, a developer, JavaScript developer, do you think that like it's something that you just cannot avoid, like something you will come like across at some point in your career?
Nice, yeah. So I think it's interesting because like the tooling has changed so much over the last, I don't know, 4 or 5 years. And somebody tweeted this out, and I don't remember the name, but he's like a famous JavaScripty person. And he was like, eventually like we'll all become compiler engineers. And I saw that tweet and it like shook me like a few years ago. And that's when I started investing the time in this. I was like, what? I don't want to do this. I like want to make buttons clickable and stuff. Mm-hmm. But honestly, it's super cool and it is super approachable with all the great resources we have now. Like even things like abstract syntax trees, they're not a JavaScript concept, right? They're a computer science concept, and there's so many resources like Khan Academy and Coursera and all that fun stuff. Mm-hmm.
Okay, so one more question here. Is there a particularly good place to find pre-existing code mods?
Nice. So there is this awesome Codemods repo on GitHub, so I would start there. And honestly, like the strategy I've taken is I've Googled like thing I want to do, Codemod, and I've taken a look at implementations by engineering teams at larger companies. We saw the one for Lyft where they took the React prototypes and converted them into actual TypeScript types. And that's always a good starting place. It is very hard to write a Codemod from scratch, so I would say find a reference example and use that reference example to meet your cases.
Okay, thank you so much, Simon. Let's give him one more round of applause.